Hi everyone, it's Mrs. Summer here to discuss atomic structure. In this lesson, students will be able to define an atom, identify the location of the subatomic particles, the proton, the neutron, and the electron, identify the relative mass of the subatomic particles, and identify the charge of each subatomic particle. So what is an atom? An atom is the smallest unit of matter that retains all of the chemical properties of the element. So how small is an atom really? Roughly, an atom is about 10 to the negative 10 meters, or 0.00000000010 meters. And if we look over here, atoms are extremely small. They are about this centimeters wide, 0.000000001 centimeter wide. To make the atom a size of a football, or in other words, an American soccer ball, it would have to be enlarged by about 3 billion times. So to make the atom the size of a soccer ball, you have to enlarge it by 3 billion times. That's just how small an atom is. If you're able to, you can check out the scale of the universe, but it might not work on your Chromebook because it is a flash player necessary tool. So an atom has two regions. The nucleus is the center of the atom over here. And I'm using purple because, red and blue, they make purple. It's where your mass is. The nucleus is the mass of the atom. It's this tiny thing in the center of the atom that has all of the mass of the atom. The electron cloud is all of this space around it. So we've got all of this space around the nucleus. And it's the area around the nucleus, it's the volume. And this is what takes up the volume of the nucleus. It is the area where an electron may be found. So in different regions are different subatomic particles. So an atom is made up of 3 subatomic particles. You probably remember this from 8th grade science. A proton, a neutron, and an electron. The protons and neutrons, and let me change my color. The protons and neutrons are located in the nucleus. So we've got the nucleus. The electrons are located in the electron cloud over there, but not in here. Okay, subatomic particles, the proton, it's positively charged, positive proton, easy to remember. The relative mass of a proton is 1. And then its location is in the nucleus. Neutrons are neutral. So don't think neutrons negative, think neutrons are neutral. They have no charge. Okay, they have no charge, but they do have a mass. So their relative mass is 1 and it's located in the nucleus. Electrons are negative. I don't really have a good way of remembering that. Other electrons are negative. Its relative mass is 0. An electron cloud it's located in the electron cloud. So if you think about the relative mass, electrons have very, 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 very tiny mass compared to a proton and neutron. So when we're comparing the two, that's where electron has no mass and the proton and a neutron each have its own mass. So proton and neutron each have their own mass of 1. A relative mass. If you take AP chemistry, you'll find out the true mass of the protons and neutrons and electrons. But for all this purpose, protons, their relative mass is 1, neutrons' relative mass is 1, electrons' relative mass is 0. Okay, protons positive, neutrons neutral, electrons are negative. Write that stuff down in your notebook. Write this whole table down in your notebook, because you're going to need to use it for the rest of this unit. Also be really careful because a lot of students confuse the charge on an atom. They confuse this charge with relative mass. The relative mass is in relation to other things. How much does it weigh? The charge is what is important for the most part in this unit. So knowing that protons have a positive charge, neutrons are neutral, and electrons are negative. Don't confuse charge and relative mass. Also, from here on out, we'll be using abbreviations. So for protons, we'll do this with a superscript of a plus sign. For neutrons, we'll do this in a superscript. We usually just write it as, N naught or N0. Not really with that center and the little dot in the middle, just N0. And electrons are E minus. Just, it shows the relative charge of each of the particles.